Morning, my name is Father Rayappa, and you are watching my Cosmology series of talks. Today's segment number is 34, and I'm going to talk about our sun. The sun is chemically composed of hydrogen and helium. The two elements came from the Big Bang process and account for 98% of the celestial object's mass. The remaining percentage is accounted for by oxygen, carbon, neon, iron, magnesium, nickel, chromium, sulfur, and silicon. And it is mostly made up of hydrogen and helium. It has core, it has got the radioactive zone and also convective zone, and then the photosphere, the solar atmosphere, neutrinos, radio emissions, X-rays, prominence, and solar flares. According to astrophysicists, core is the hottest zone or part of the sun. It is believed to be at a temperature in the region of 15.7 million Kelvin and under a very high temperature. The high temperature and pressure cause nuclear fusion, which involves the atoms of hydrogen and helium combining together. The process gives out light and heat, which penetrate through the other zones to the Earth and remaining parts of the solar system. The core occupies 25% of the star's radius. The radiative zone, the temperature is much lower than in the core. It ranges from 2 to 7 million Kelvin, depending on the distance from the core. The ions of hydrogen and helium are responsible for energy transfer in this layer. Radiations from the core lose a lot of energy when passing through this zone to the Earth. Life would be unbearable, or there would be no life on the Earth if the region doesn't absorb some of the radiation's energy. The region takes 70% of the star's radius, making it the largest in the celestial body. Then comes the convective zone. This is the outermost layer of the sun. It consists of heavier materials that are partially ionized. The temperature falls to about 6,000 Kelvin and heat transfer takes place through convection. The zone extends to another layer surrounding the star known as photosphere. So now we talk about the photosphere. This is the part of the sun that we see from the Earth. The upper region is cooler than the lower region, and this is the reason why the center of the solar is brighter than the edges. Studies show that there exists some water and carbon monoxide molecules in the cooler region. The temperature of this zone is less than 6,000 Kelvin. Let's talk about the solar atmosphere and its important part and featuring of the sun. The solar atmosphere is divided into three zones: chromosphere, corona, and heliosphere. Chromosphere, this is a 2,000 kilometer thick layer that is filled with the colored flash of emissions and magnetic flux lines. It is the innermost layer of the atmosphere and consists of a partially ionized helium. Its temperature lies between 6,000 Kelvin to 20,000 Kelvin. Then comes corona. This is the second hottest zone of the star after the core. Its temperature ranges between, between 1 million Kelvin and 2 million Kelvin, and it consists of darker, less hot regions known as coronal holes or sunspots. Another interesting feature of the corona is the solar wind, which consists of waves that blow away from the zone to other parts of the solar system. The waves are commonly known as coronal plasma or loops. Then comes heliosphere. This is the outermost layer of the solar atmosphere. It is filled with energetic particles as well as the solar wind and is believed to be felt in all planets. The other features and components are neutrinos, they are microparticles produced during the fusion reaction. There are radio emissions. They are formed when magnetic field lines interact with elements on the surface. Then comes X-rays. They are formed when the sun's magnetic field gets twisted up. Then comes prominence. It is a bright loop-shaped feature that extends above the surface. At last, solar flare. A sudden bright flash that happens near the surface. I have a video animation for you on the sun. So I would like to share that video with you.
The sun consists of an inner core, a radiation zone, and a convection zone, and also has an inner and outer atmosphere, referred to as the chromosphere and the photosphere. The latter two are the layers where visible solar activity takes place.